layers, we are going to make a ratio that is going to help us to make that decreasing of that vertical module. That ratio is going to be equal to EV of the top divided by the EV of the subgrade everything to the power of 1/5. So can you help me with that one? EV of the top being 450 and EV of the subgrade being 100. Everything to the 1/5. How much you got? Two point something?
Yes. 2.12.
No, not 2 point. Yeah, 1.35. 1.35 check. 1/5 has to be in brackets.
Yeah, but I know what is the number.
450 divided 100 to the power of 1/5. Yeah.
Okay.
450, 100, 1/5. Okay. So if that is my ratio of moduli, then this one, well, we actually call it the opposite. So this one will be the top layer 5, layer 5, layer 4, layer 3, layer 2, layer 1, and the subgrade. So layer 4 is going to be EV of the subgrade times R to the power of 4. This one will be EV of the subgrade times R to the power of 3. EV of the subgrade times R to the power of 2. And EV of the subgrade times R to the power of 1. So how much is that? Can you do all those four for me, please?
Porque es EV del subgrade, que es 100, ¿no? Porque el 450 es de EV top, ¿no?
O sea, es 200.
Es 100, y después EV top, dividido EV subgrade, EV top es 450, y EV subgrade es 100, ¿no? Y ya estamos diciendo...
Es por el CV.
No, mira.
So how much it is?
EV subgrade es 100. Mira la fórmula.
Sí, ¿no?
Ahí está. Y R es 1.1.
And then this one?
50.
El subgrade es 100.
146.
0.04.
Ok,
182.
puta, no, que vamos a entrar completo. Aquí está el resultado. Estamos mirándolo incompleto, ¿no?
135.1.
105.
Okay, so
No, pero igual está mal.
in this way, we are able to know how much is the elastic parameters of each of the sub-layers that we have in our pavement composition. If we know the vertical module, we can know everything else. The horizontal will be half of this one. The Poisson's ratio is going to be 0.35. And then the stress parameters is going to be the relationship between the vertical and the Poisson's ratio. So it's easy. So the other things that we need to do is just to calculate the horizontal, which is half, the Poisson's ratio, which is 0.35, and the stress parameter, that is the vertical divided 1 plus b. Okay? We are not going to do them because it's kind of easy. That is how we analyze the granular materials. The modified materials are materials, so we can have three types of materials: the granulars, unbound ones, the modified ones, and the bounded ones, right? So the unbound granular materials, we analyze it like this. The modified granular materials, we analyze them like this as well. So a modified granular material is a material that has a little bit of binder. So a little bit of cement, a little bit of bitumen, or a little bit of lime. And that make that material a little bit stronger. How stronger? Around 1 megapascal stronger. But that's it. So because the amount of binder that we are adding is not that big, we still consider it as an unbound material, and we analyze it as if it was an unbound material. Do you know what is lime? Cal? Cal. So, but I don't know in Turkish. How do you say cal in Turkish? I don't know. So, but the lime is that white powder that is really good because it absorbs moisture. So one of the properties of the lime is lime can absorb humidity. So it will catch that water and will trap that water in the molecules, and then it will not affect the soil itself, right? So sometimes that's why it's very useful, especially if we have clay soil. Because if you remember, a clay soil has the property of expanding every time that it touches water. If we can avoid that using lime, it will not lose its strength and it will not have those volumetric changes that it usually has. The other type of material is the bounded material. That is going to be a material that has a lot of binder. So it has a lot of cement, or it has a lot of bitumen, or it has a lot of lime. And then it's going to be considered like one element, like very thick element, and they are analyzed a little bit different. So when do we? I just said that. When do we use limes, especially for clay soils? When do we use cement? When we want to increase the capacity of that base or granular material. Asphalts are the most common bound materials that we use as base, are the most common ones. So we can also use a cemented granular material that is going to be a bounded material, but it's the most common that we use, especially in urban roads, is the asphalts. So asphalts are materials that we do in the lab. So we create them with a specific vertical module. We create them with the specific Poisson's ratio. So it's fun, it's fast. It's easy to control its properties because we create them, right? With the other ones, we have to mix a lot of materials together to find the properties that we want. In this one, we do the same, but it's it's under a lab, it's controlling. The other one we do it on site, or quarries does it for us. But it's similar, but it's not the same. So, what are the most common components of an asphalt? Well, an asphalt is done by coarse aggregates, fine aggregates, fillers, bitumens, and airboats. Coarse aggregates are those aggregates that has a size bigger than 5 millimeters. So if the size is bigger than 5 millimeters, we are going to call that a coarse aggregate. Those are the ones that are going to resist the most. Those are the ones that are there to receive the loads because they are done with very high standard crush rocks, so they are strong enough to resist the loads. That's why the more coarse aggregate you have, the stronger their pavement composition is going to be. Fine aggregate is perfect to fill all the gaps. We need to fill the gaps because we don't want a lot of air in our pavement because then we have this air resisting the loads. So we need fine aggregates to fill all those holes. But still we need air because we need to allow particles to accommodate a little bit, but we have air voids, that's why we have air voids, but we have to limit those air voids that we could have in our pavement. Filler is, so coarse aggregate is until 5 millimeters. If it's smaller than 5 millimeters, we are going to say that that is a fine aggregate. For example, sands. Sands are fine aggregates, and they are used to fill all those gaps. If it's smaller than 0.075 millimeters, is what we are going to call is a filler. What is smaller than 0.75 millimeters? Cement, limes, all those dust that we use, that is going to be a filler. You were going to ask them?
Yes, which we use the type 4 material
As a base or sub-base? No.
no, as a fine aggregate. You see that it's only for fill, just as a filling?
No. But filling, when you are doing a road, for example, this is the mountain, right? So it's a different kind of filling.
Oh, okay.
So, and you need to cut your mountain, right?
Yes.
And then here, you have to fill.
Oh, okay.
But your pavement composition will be on top of this,
I see.
right? So for filling the part that is not part of your pavement
Then
composition,
it's
you use type 4.
oh, okay, got it.
But type 4, but here, the filler here is in the inside the composition, inside the granular material, and it's going to be something really, really fine, like dust, like cement, like limes, things like that.
Right, thank you.
But yeah, good question. So after we know how much, now that we know what is a coarse aggregate, what is a fine aggregate, and what is a filler, we need to stick that with something. When we are doing asphalts, we stick that with bitumen, that black sticky thing. So if you see this and you change this with cement and this with water, you are going to have a concrete. So concrete is exactly the same, coarse aggregate, fines, and fillers. But if you change this bitumen, instead of bitumen, you have cement, that you are doing a concrete. So here we call asphalts as asphalt concrete. If you see when they name the asphalts, they say AC, they say AC14, AC20. What does it mean? Asphalt concrete 14, asphalt concrete 20. And what does the 14 mean? What do you think? Portion of something, size of something. No, thickness of something, no. It's the size of the biggest size of the coarse aggregate that we have. Because the coarse aggregate is the one that is important for us. Because it's the one that, so which asphalt do you think that is going to be stronger, an AC20 or an AC14? 20 has more capacity. Which one is going to be more sealed, AC14 or AC20? 14, because it's smaller, so they will fit together better. So usually we use an AC10 or AC14 as a wearing surface, and an AC20 or an AC24 as a base. because the other one is strong because it has big aggregate, very strong aggregate, and the other one is very sealed. It's not letting the water pass because it's smaller the size of the aggregate. So that's usually how if we are doing, for example, a full depth asphalt, a pavement composition that is asphalt as wearing surface and asphalt as base, we combine an AC10 with an AC20, for example, an AC14 with an AC24. One working as a wearing surface, the other one working as a base, right? So usually it's bitumen. We call it like C320, C450, C170. Those numbers, 170 to 40, is the viscosity of the material at 60 degrees. So how much viscosity has that material when it's heated to, up to 60 degrees. So the bigger the number, the more viscosity it is, so it's more sticky, like less watery. So it's better for asphalts. If we are going to do an asphalt, we want it to be very sticky because when it gets hard, it will be like very well bounded. If we are doing a wearing surface, for example, a spray seal, we cannot have it that sticky because we want it to spray. So if it's very sticky, imagine spraying something very sticky, it's hard to spray. So we want it to be more kind of liquid, watery, so we allow to have a smaller a smaller classification, for example, the C170. We allowed it to have less viscosity, so we can actually spread it better. So when we are talking about asphalts, we usually use C320, C450. If we are talking about the spray seals, we usually use C170, which is easier to spray, right? Now, at the long time ago, there was just bitumen that we were using. Now we use, normally now we use the polymer modified binder. That is a bitumen that we add like rubber, like the rubbers or the elastics, little chopped rubbers, because it increased the property of elasticity of that binder. So nowadays we usually use the polymer modified binder. That is the most common one because it's a bitumen that has been improved with technology. So that's the one that we use most of the time. Time ago it was like bitumen. There was only bitumen, so that was what we were using. But now with technology, we have discovered that we can improve the properties of that, and now we are using the polymer modified binder. We can add additives to asphalts. What type of additives we can add? Many. We can add one that is a cellulose fiber that will increase the strength of the asphalt. We can add, there is a liquid that makes the asphalt keep warm for more time, because sometimes we need to place the asphalt, but because it comes from far away, when it gets to us, it's cold, and we cannot place asphalt cold because it's hard to work with it. So it has to be really hot to place it. I don't know if you have seen when they are doing that in the streets. Yeah? That you see that the trucks come very hot and it falls down like lava, kind of. And they just move around, they just spread it, and then with the machine, they spread it and then just compact it. Well, it has to be really hot. So if it comes from very far, maybe you need to add some additives to keep it warm. It will make some chemical reactions to make it stay warm so you can use it. Otherwise, you cannot place it. What else? There are many additives that you can use. And finally, we have to know how much air voids we are allowed to have, right? So when you mix the asphalt, when you are preparing the asphalt, air is going to be trapped. That's normal. But then you need to kind of shake it to make the air get out. But if we don't want, but sometimes we want air inside our pavement or our asphalt, depending on the type of asphalt that we are designing. So the standard gives us the maximum percentage of air voids that we could have. So a normal asphalt, that is the dense graded asphalt, that's the most common one, an AC14 dense graded asphalt, is going to have around 6% of air voids. And an open graded asphalt, that is another kind of asphalt, could have air voids of more than 20%, right? but they have different uses. This one is not that strong, obviously, 20% of it is air. But this one is really good to allow water to get inside and reduce the water mist. When you are driving and it's a very rainy zone, for example, there is a lot of water mist and you lose visibility. This one, because it's full of gaps, because it has a lot of holes, the water is going to get inside that, and then when the trucks pass, there is not a lot of water sprayed out, and it's not affecting the visibility. So there are many things that you can, change something in your asphalt, and you can make it useful for other things. This one, you need to make sure that you have, because water is going to get inside that pavement, you need to be sure that you know how to drain it, right? This one, you are getting sure that the water is not going to get inside. So there are many uses and many types of asphalt. So how we combine, the most common ones that we usually use are these four. The one that we use the most is this one, the dense graded asphalt. We use it for like the basic one. It has a lot of coarse aggregates, a good proportion of fines. It has a good amount of fillers, bitumen, and air bonds. The strongest pavement that we have, the strongest one, is the stone mastic, the strongest asphalt, this one. It has more post aggregate, less fines, and much more fillers. And remember that fillers can be cement, can be the cellulose fibers and things like that, and has more bitumen. This is the strongest one. This one is, this one, the open graded asphalt, is the one that has a lot of air voids. It's not that strong. It has a lot of air voids, but they are created for something, right? This one is for every day. This one is for very strong needs, airports, ports, specific places where you need a strong pavement. This one, for specific needs, you want water to be high and you need to drain the water under the pavement, not above the pavement. So this one is perfect for that. And the last one is the fine gap graded asphalt. It has a little bit of coarse aggregate and a lot of fines. So if you see this one, it will be very smooth, very sealed, because it has a lot of fines, but not strong, right? So this one has other specific uses. So usually we use it as wearing surfaces because we want it just to be sealing our pavement, right? So they are all created for different needs. There are way more. These are the most common ones. So I just write down what I just said. So dense graded is for general purposes. Is used well graded granular materials. The open graded is for water permeable, so it's allowed water to pass. The stone mastic is the strongest one, and the fine gap asphalt is the weakest one. It's very weak. But if you see the photo, it looks like really smooth. So let's have a break, and then we do the example. Or no, let's do, what time is it? Let's do the other PowerPoint, and after the other PowerPoint, we do the example. Yeah?
Okay. I just got a question.
Yeah.
In the 25
page.
the page,
Yes.
Yeah.
is that like the order of the materials?
Like the proportion. No, but they are all mixed together.
Yes.
Oh, okay.
They are all mixed together. That's like the proportion. How much of this, how much of that, how much of that. But they are all mixed together in like when you do a cake, exactly the same.
Okay.
You have this amount of egg, this amount of butter, this amount of flour, this amount of sugar, right? But you mix together,
All right.
right?
Got it. So that will be-
Okay. So let's do the other PowerPoint and then we do the example.
There you go.